Good afternoon, everyone. This is Christian Roberts. I'm back with another video, and today we'll be discussing seizures, and we're going to be discussing the mechanism regarding what happens to a seizure and how seizure is inhibited or prevented. So we're going to talk about understanding the GABA and the Vigabatrin and the mechanisms of inhibition and seizure prevention. So before I move on, I kind of just want to talk about the idea of what a seizure is. A seizure is considered a sudden, uncontrolled burst of electrical activity in the brain which can cause us a lot of changes in behavior, movement, feelings, and levels of consciousness. And if you have a seizure within a certain time frame more than one time, then you might be considered epileptic. And the causes of seizures are usually high levels of salt or sugars in your blood, or a head injury from a stroke, or a head injury of basically brain problems that was basically hereditary from the beginning, or probably a brain tumor that you probably had that you probably got cured for. So it's a lot of kind of causes to it. But as I proceed along, I want to talk about the GABA, which is considered gamma amino butyric acid and is considered a crucial neurotransmitter in the central nervous system. It functions as an inhibitor of a neurotransmitters. Basically, it reduces neuronal excitability, which will lead to the inhibition of neural signaling. So basically, in other words, it's going to prevent the seizure by basically kind of throwing off the neural excitability, basically throwing off the signaling. And once that GABA neurotransmitter throw off the signaling, then the seizure is most likely will be prevented. So I would like to go in more into detail about what a GABA receptor is. A GABA receptor is considered to be responsible for the neurotransmitter, and it is the chief inhibitory compound for the mature vertebrae of the central nervous system. So as I clarify, it is more of the mature compound, so it's the most reliable. So as I continue on, I will also like to go into detail of what a GABA receptor is. GABA binds to specific receptors which circulates around the postsynaptic neurons, which is better known as the GABA receptors. There are two main types of GABA receptors, which is GABA A and GABA B. GABA A is more common than GABA B. The activation and it takes place in two different stages. The activation of the receptors will lead to the hyperpolarization of the postsynaptic neurons, which will make it less possible to fire an action potential. So basically, once they're activated, the hyperpolarization concentration is going to increase, which is going to make it more harder for the signaling of the neurons to be met. So as I continue, see, this is the diagram of the GABA receptors. This is GABA B heteroreceptors, and this is the GABA A receptors. Notice how the GABA A receptors is basically receiving. They are basically considered like they have a ligand gated ion channel. That's what GABA A receptors have. They work in different they work in different ways. Don't get me wrong. They work differently, but the thing is that when GABA binds to the receptors, the result is that the responsiveness of the nerve cells will decrease. So the purpose of GABA binding is just so the signaling can just be reduced. So like I said, this is the idea and the layout of what happens during like when the seizure or the components or the enzymes that can cause a seizure could be inhibited. And that is the natural receptors. Now we can go into the mechanisms of action. So I'm gonna say when GABA binds to the GABA A receptor, it opens chloride channels, which will allow the chloride ions to enter to the neuron. And then once it enters to the neuron, then which is I'm talking about the chloride channels. Once the chloride channels into the neuron, the influx of the negative ions will then polarize the neuron, which will make it less likely to reach the threshold for firing an action potential. In other words, once that chloride channel is what's traded and once it's in the possession of the GABA A receptor, then the neuron signaling is going to dim down to the point where it's going to be impossible for the seizure to continue on. Consequently, GABA inhibits neuronal activity, which is serving as a regular regarding brain function. So this is regarding brain function. So as I move on, now we can talk about the Vigabatrin mechanism of action, and this is the idea of the mechanism of action. So let's talk about Vigabatrin a little bit. So Vigabatrin So Vigabatrin is used basically with other medicines to treat refractory complex partial seizures in adults or children, which is 2 years or older. Basically, so it's an antibiotic that is made in place for GABA A receptors to treat that to inhibit that transmitter, to inhibit that specific enzyme that can commit the extra cells and to commit the signaling activity to proceed along for the seizure. So this is the structure, and this consists of NH2 and H2O. And this is, mind you, keep in mind, this is artificial. This is not the essential. This is unessential. So this was man-made just so we can calm down the seizure, or we can calm down whoever is dealing with epilepsy. So as I move along, we can talk about Vigabatrin and seizure prevention. Excuse me. Vigabatrin is an anti-epileptic drug that works by increasing the GABA levels. So basically, it helps increase the GABA levels by inhibiting the enzyme GABA transaminase. So if I go back to this slide, you can kind of see, where the Vigabatrin, it links with the GABAs within the cells and everything, how it's linked up, just so it can increase concentration for the GABA, just so the neural signaling could be dimmed down or be sabotaged. So I'm gonna continue on this slide. And then I also want to say, by inhibiting the GABA transaminase, the Vigabatrin enhances the GABA levels, leading to the increase of inhibitory activity within the brain. So like I said, been saying all along, without the power of GABA, without the power of Vigabatrin, the GABA receptors could only do so much. But with the help of Vigabatrin, it can allow the GABA receptors to do more things because it consists of the same components. It'll be easier for the GABA to move around and stimulate and to cancel out other neural signaling regards to whatever parts of the brain. So as I continue on, this is the mechanism of seizure prevention. Seizures occur due to, like I said, excessive neuronal firing, or synchronization of neuronal activity. By enhancing GABA, basically a GABA antibiotic or GABA neural or autoreceptor type of inhibition, the Vigabatrin will reduce the neural excitability and prevent the spread of abnormal electrical activity associated with seizures. This mechanism will help control the various types of seizures, including those associated with epilepsy, like I said before. So, inclusion for the conclusion and future predictions. Okay, so what we concluded is the GABA function acts as an inhibitory neurotransmitter by raising the concentration of high polarization to the postsynaptic neurons, and the Vigabatrin helps the GABA, preventing the neuronal signaling in between each other, just so the seizure could stop or die down. So the brain activity is going to be regularly stimulated, it's going to be back regulated, and reducing the excitability of neurons will be reduced as well, and it will not be much of an issue because it's going to be at ease. Now, there's no exact cure for seizures, but it could be managed. It could be managed, but you just got to be cautious. And then throughout this presentation, we understood the role of GABA and drugs like Vigabatrin, which provides insight into the treatment of epilepsy and other neurological disorders. So there's really no cure, but as long as you are very cautious, and then with people who are epileptic, make sure if you want to go and move somewhere, it's best for you to drive. It's best for you to ride with somebody instead of driving, because when you drive, your mind can easily function. It can mistake that you're having an attack, and you can easily get into a car accident. So I prefer people who are known to have seizures not to drive. Always have somebody with them or near them when it comes to certain moments, like if you're getting overheated or if you're being down or whatever. Always have somebody to be there for you, and make sure you take the proper medication that is prescribed by your clinician. And I am done with this presentation. I hope everybody got an opportunity to learn something today. And these are my works cited of what I've showed you. Remember, seizures and epilepsy is not really a bad thing. It's really a genetic thing, but it could be monitored. So whoever is dealing with seizures, go to your doctor, and your doctor will have the best solutions. Thank you.